Hello everyone, I hope you all are doing good and perhaps you might be going through my videos too. I know the sound quality for the video is not up to the mark, but I'm surely working on it and you will obviously see the changes in the coming videos. Now, I will continue from where I have left in the previous video. So at the end of the previous video, I have given you one question. So from that portion itself, I'll continue it. So this was the question. I have given you 3 alcohols and I have just asked you about the ease of dehydration of these alcohols. Now you might be going through the mechanism portion too. And I have already told you in the previous class that it is the stability of the carbocation. The stability of the carbocation formed by this alcohol is the sole factor which is responsible for the ease of dehydration. More stable the carbocation, the ease of dehydration will obviously high. That means that alcohol will easily dehydrate it. So you must only understand this topic that more stable your carbocation, the ease of dehydration will be fast. So from these 3 alcohols, in the mechanism portion, I have told you that in all the alcohols, the oxygen atom will obviously bear a lone pair. And that lone pair of electron will attack H plus ion or the proton from concentrated sulfuric acid, and it will ultimately form H2O. In this portion H2O, it will also form H2O and this will also form H2O. And after that, this water will be eliminated. So it will get rid of water molecule, and after it gets rid of water molecule, it will form the corresponding carbocation. And if this OH water molecule is lost, the carbocation formed will be like this. So this is the carbocation that will be formed from first alcohol. Similarly, if this gets rid of water molecule, it will obviously form this carbocation. The plus charge will be in this position. And if this water molecule is lost, the carbocation formed will be like this. This carbocation will be formed. So this is the carbocation. Now among these 3 carbocation, the most stable carbocation obviously means the ease of dehydration will be faster. So among these 3 carbocation, you must always be able to judge which carbocation will be most stable. Now, let us refer to this carbocation, plus charge and the double bond present with the same carbon atom. This carbocation is one of the most extremely unstable carbocation, and they are usually referred as vinyl cation, and vinyl cations are one of the most unstable carbocation. And if this carbocation is unstable, the ease of dehydration of this alcohol is very, very slow. It might not be dehydrated at all. But if I consider this another carbocation coming from this alcohol, in this carbocation plus charge, there is a single bond after that and there is a double bond. That means here the condition of resonance is being fulfilled. Now plus charge, single bond and double bond, the double bond is present at the conjugation with the plus charge. That means it will obviously undergo resonance. So it's double bond. Since plus charge means this carbon is electron deficient, and a double bond means obviously double bond will have more electrons. That is why the double bond will be shifting in this position. And if double bond gets shifted over here, another resonating structure will be like this. You can simply refer this one. So here there will be a double bond, and due to the shifting of this double bond over in this position, the plus charge will be coming in this position. Now what is happening? This is the original structure and this is another structure. That means this carbocation is actually forming 2 resonating structures. That means this is obviously undergoing resonance and it is forming 2 resonating structures. And this type of carbocation where plus charge, single bond and double bonds are present, they are simply referred as allyl cation. Okay, now let us consider this one. Here, if you see it properly, plus charge, single bond and double bond, that means obviously the condition for resonance is being fulfilled. If you draw the resonating structure, it is not necessary to draw the resonating structure, but if you understand it, that will be sufficient. This plus charge, single bond, double bond, that means the plus charge will be shifted in this position. Again, if you can consider this plus charge, single bond, double bond, that means it will obviously move that side. That is why the plus charge will be shifted in this position. Again, plus charge, single bond, double bond, that means plus charge will be shifted in this position due to the shifting of this double bond in this direction. That is why the plus charge is actually moving all throughout the benzene ring, and that is why here the resonance, the total resonating structure will be 4. Because plus charge is moving at 4 different directions, that means this is actually undergoing extreme resonance. And this type of carbocation where there is a benzene ring, after there is a single bond and a plus charge present, that means this type of carbocation is actually known as benzyl cation. And the stability of benzyl cation is much higher than compared to that of allyl cations. And allyl cations are much more stable than the vinyl cations. Vinyl cations are one of the most extremely unstable carbocation. That is why, since this is most stable, the benzyl cation is most stable, that means the given alcohol, the corresponding alcohol will be most easily dehydrated. In the second one, it is the allyl alcohol, and after that will be vinyl alcohol. That is why the ease of dehydration will be C, will be greater than that of B, and after that it is A. So this is how you must be answering it. Okay, now we'll solve some questions, especially for the NEET and the JEE students. So these are the type of questions that you might get. Okay, so which of the following is not the product of dehydration of this given alcohol? That means among these 4 options, one of the option is not the dehydrated product of this given alcohol. Okay, so which is that? Let us do it. So this is your alcohol. OH is attached with this carbon, and that is simply referred as alpha carbon. And here there is a beta carbon because the carbon which is associated with the alpha carbon, that is referred as beta carbon. Similarly, this is also a beta carbon. Here lies one carbon atom. Obviously, here also there is another beta carbon atom. Now, we all know that during dehydration of alcohol, hydrogen will be lost from the beta position and the OH from the alpha positions. That is why in between alpha and beta positions there will be a formation of double bond. Okay, so that means in sub number A, here obviously with respect to this structure, this is your alpha position and this is your beta positions, and between alpha and beta there is a double bond. That means this is a dehydrated product. Obviously, the dehydrated product of this alcohol, this one is the dehydrated product. Similarly, this one also, if this is your alpha carbon, this will be your beta carbon, and between alpha and beta there is a double bond. That means this is also a dehydrated product. Similarly, number C, here this is your alpha carbon, and you know that this is a beta carbon. Between alpha and beta there is a double bond. That means this is also a dehydrated product. If you consider product option number C, option number B, what happens? This is your alpha position, and with respect to this is your alpha position, and this is your beta position, and here lies the gamma position. Another carbon is referred as gamma position. Now between gamma and beta carbon there is a double bond, but usually we need to have double bond in between the alpha and the beta positions. But since there is a double bond between beta and gamma carbon, so this is incorrect. That is why option B is the correct option. So this is how you must be trying it. Similarly, let us focus on another question. Which of the following alcohol undergoes dehydration faster? Or perhaps you know about it. We have already discussed about it. You know that the alcohol which will form a more stable carbocation, that will obviously undergo dehydration faster. Okay, so let us try it. There are 4 alcohols. We know that in given alcohol, the OH will attack H plus ion, that is why H2O will be formed. So this will be ultimately removed and the positive charge will be residing in this position. Similarly, OH will be removed, ultimately being what will be formed, that is why it will be removed, that is why plus charge at this position. Here also the same thing, OH will be removed, so plus charge will be formed in this carbon, and similarly OH will be removed from here, the plus charge will be developed at this position. Now since plus charge, there are no double bonds in conjugation with the plus charge in neither of these 4 carbocations. That is why they will not undergo resonance. But to explain about the stability, there are other factors too. So let us take hyperconjugation into account. So plus charge is present in this carbon. So with respect to this position, with respect to a positive charge at this position, let me refer this as an alpha carbon. Now, if this is your alpha carbon, it is forming 2 bonds. That means it will obviously have 2 hydrogen atoms. And if alpha carbon has 2 hydrogen atoms, it will undergo 2 hyperconjugation. So basically, there will be 2 hyperconjugation in this case. Here, once OH is removed, plus charge is present over here, and with respect to plus charge in this carbon, this will be your alpha carbon. Obviously, this is also your alpha carbon, and here also there lies an alpha carbon. Now, if there is a carbon present over here, it is simply forming single bond. That means it will have 3 hydrogen atoms. Similarly, this carbon will also have 3 hydrogen atoms, but this carbon, since it is forming 2 bonds, that means it will only have 2 hydrogen atoms. That means altogether there are 8 alpha hydrogen. That means 8 hyperconjugations. Over here, once OH is removed, the plus charge will be developed in this carbon. And with respect to this position, this is your alpha carbon and this is also your alpha carbon, and it will have 2 hydrogen. It will also have 2 hydrogen. That means 4 hyperconjugation. And in the last structure, since OH will be removed, the plus charge means this is your plus charge. There is a carbocation in this carbon, so this will be your alpha position. Obviously, this is also your alpha, and this is your alpha position. So here there are 2 bonds. That means it will have 2 hydrogen. It will also have 2 hydrogen, but here lies 3 hydrogen atoms. So altogether, it will have 7 hyperconjugations. So you all know that more the hyperconjugation, more will be the stability of the carbocation, and more stable the carbocation, it will undergo faster dehydration. That is why here is the option number B, which will undergo dehydration faster. So that is how you must be answering the questions related to the dehydration of alcohol. I hope this topic is clear to you all.